Okay, last time we talked about the two types of instrument, and we reached the accelerometer. So there are two types: seismometer, okay, which is instrument with low natural frequency, and it can be a velocity meter or called velometer or velocity pickup if you put a magnet mass. And then the second one is the accelerometer, which can measures directly the acceleration. And it is a commonly used sensor or transducer. Okay, the error factor for the accelerometer is 1 over square root of 1 minus omega over omega n squared, or square plus 2 zeta omega over omega n squared. And here is the graph of sum of the error factor with some values of zeta. So it is near zero, as you can see here, which is the range omega over omega n is near zero, and how it varies the error factor with zeta. Okay, an example is given here for zeta equal to 0 and zeta equal to 0.7. Okay, and if you use those two accelerometer within the range from 0 to 0.2, the one with zeta equal to 0.7 will have a maximum error of 0.01%. Okay, which is 0.003 times, right? 0.0001. That is the error, and this is the deviation from 1. So if you want the error factor, this will be 1.0001, which is very close to 1, which means that the error is very small. But when you consider the accelerometer with zeta equal to 0 within the same range, as you can see, the graph for zeta equal to 0 is sharply moving up. Okay, so at the maximum error will be at frequency ratio 0.2, which is more than 4%. Okay, so the error factor will be 1.04, and that will be the maximum. In order to check the maximum error within accelerometer, if range is given, we have to see if there is a peak or within the range. Here I gave an example about 0 to 0.7 frequency ratio, and this zeta equal to 0.65. You need to check 2 points at the end of the range and at the peak. Okay, so the peak is obtained at R peak, which is square root of 1 minus 2 zeta squared, and this is in the formula sheet. So it is obtained by taking the derivative of the error factor, make it equal to 0, and then you find R. That will correspond to the peak point. Anyhow, this is made ready for you in the formula sheet. Okay, so we will talk about the tutorial today. Okay, in the tutorial, I have mentioned that there will be any questions, Sayed?
No, doctor.
Okay. Okay, so because I hear the echo is coming back to me. Okay.
Sorry, my mic fell down.
No, okay, no problem. As I said, there are two types of instruments: the seismometer and accelerometer. But in the references for the seismometer, they sometimes use velocity pickup, sometimes they use a velometer, or they use other name. But I hear focusing on using seismometer so that you don't get confused. Okay, so I will use either a seismometer or accelerometer so that you know we have only two types. Okay, question number 1, determine the maximum percentage error of a seismometer in the frequency ratio range are greater than or equal to 4, less than or equal to 8, infinity, sorry. So with the damping ratio of zeta equal to 0. The seismometer graph or the error factor of a seismometer is Z over Y. Okay, so the maximum will occur at the maximum error will occur at resonance because we'll have here error factor goes to infinity, but the frequency ratio given in this problem from 4 to infinity. And we know that the graph for a seismometer, the error factor will become asymptotic with 1. So that the error factor will go up this way, and then this is at resonance, and then it will decay this way, become asymptotic with the line 1. So R equal to 4, if this is R, which is the frequency ratio, starting from 4, here is 4, let's say. And then it will decay. This is open to infinity. So as you go away from 4 to the right side, you will have the error will be less. So the maximum error occurs at 4. This will give you the maximum error. Okay, so we can use the error factor equation, which is EF equal to Z over Y equation for undamped system. This is R squared divided by 1 minus R squared. Okay, I will take the absolute value. For zeta equal to 0, the graph, this is given the absolute. Otherwise, if this is not the absolute, this will come from here. Negative. Okay, so I will use the absolute. Okay, and we put 4. This will be 16 divided by 15. And then we can calculate this value. It is 1.0667. This is the error factor, but the question is to find the maximum error. So the error that at 4 is the maximum equal to 1 minus the error factor, and this will be 0.0667. And you can give this as a percentage. This will be 6.67%. Okay, question 2. A seismometer has a natural frequency of 5 Hz. This will be Fn. And a damping ratio zeta equal to 0.5. Find the lowest frequency that can be measured with a 1% error. Okay, so we have the error is equal to 1%, and the error factor will be either 1.01 or 0.99. The criteria for this is one of them is right, either 1.01 or 0.99. One of them is rejected. So we need to check the error factor at peak, and then we can decide. Okay, so first of all, we find R peak, which is 1 over square root of 1 minus 2 zeta squared, right? Zeta is 0.5, so this will be 1 over square root of 1 minus 2 multiplied by 1 over 4 which this will be square root of 2. Okay, square root of 2, which is 1.4, and then substituting in the error factor. So this is error factor at peak is r peak squared divided by the square root of 1 minus r peak squared whole squared plus 2 times zeta, which is 0.5 here, r peak squared. Okay, so let me just use zeta, 2 zeta r peak squared. Okay, we substitute for r peak, it is square root of 2, so this is 2 divided by square root of 1 minus 2 squared, square root of 2 squared becomes 2 whole squared plus 2 times 0.5 times square root of 2 squared. So this becomes 2 divided by 1 plus 2, which is 3. So this will be 2 over square root of 3. Okay, this is the error factor, which is equal to in decimal places is 1.15.
1.15, yeah.
1.15. Okay, let's say 155. And this is the error factor. The error at peak is equal to 1 minus the error factor at peak. So this becomes 0.155. In percentage, this is 15.5%, which is greater than 1%, the given maximum error. Okay, so in this case, we should, because of this, we will use the error factor equal to 1.01, because the graph is going to be something like that. Okay, try to make it sharp. Okay, here is the R peak, and this value is 1.155. This is the error factor. So 1.01 is somewhere here, and 0.99 is somewhere here. So we cannot take 0.99 because this would include regions of the range in which the error factor or the error is greater than 1%. Okay, so this case we use error factor equal to 1.01. Okay, and then we substitute with 1.01 equal to r squared to find r. Square root of 1 minus r squared all squared plus 2 times zeta here is 0.5 times r squared. Okay, so this is r squared divided by square root of 1 minus 2 r squared plus r to the power 4 plus r squared. Okay, which is r squared divided by square root of r to the power 4 minus r squared plus 1. So you solve for r. Okay, so solving for r, it means squaring both sides. And then you find there will be 2 values for r. Okay, so which one we choose? We choose R2 greater than R1 to be the beginning of the range. That is the lowest frequency ratio in the range. And then we can complete the solution by finding the natural frequency, by finding the frequency in hertz. Okay, so from here, From this graph, we will have R1 and R2. Okay, R2 greater than R1. And this is the lowest frequency ratio. So if lowest will equal to R2 times Fn. And R2 is by solving for R, we will get R1 and R2. Okay, R1 greater than R2. Okay, clear?
Yes, doctor.
Okay, question number 3. A seismometer has an undamped natural frequency of 10 Hertz. This is Fn. And a damped natural frequency of 8. This is Fd. Find the lowest frequency in the range to infinity at which the amplitude can be directly read with less than 2% error. So we have zeta is not given. We need to calculate zeta first. The first thing, okay, find zeta. And the equation for omega d equal to omega n square root of 1 minus zeta squared. We can use this to find zeta. Okay, omega d is 2 pi fd, and omega n is 2 pi fn, square root of 1 minus zeta squared. So you can see that 2 pi with 2 pi cancel out, and then you can find zeta. And the question becomes same as the question number 2, except that the error here is equal to 2%. So the error factor will be either 1.02 or 0.98. So you have to select one of them based on the error factor at the peak. Okay, so you will find our peak, and then you find the error factor at peak, and then you will compare with the maximum error, which is 2%, and then you will follow the same procedure in question 2. Question number 4, determine the maximum percentage error of an accelerometer in the frequency ratio range R greater than or equal to 0, less than or equal to 0.65 with a damping ratio of A, zeta equal to 0, zeta equal to 0.75, zeta equal to 0.65. So there's 3 questions in one question here. Okay, the idea is the range, of course, here is different. This is up to a maximum, which is 0.65. This is different than the seismometer. Seismometer works in the higher frequency ratio. This accelerometer works in the low frequency ratio, near 0. So from 0 to 0.65, that is the given range. If you want to use the accelerometer within this range, what is the maximum? For zeta equal to 0, it is always the error factor is increasing. So the error factor will be maximum at the end of the range, because the graph is increasing. There is reaching to infinity at resonance. There is no change in the behavior of the graph. So the maximum error will occur at 0.65. So directly you can substitute the error factor maximum will equal to, the error factor is 1 over 1 minus r squared. Okay, that is the error factor of the accelerometer. Okay, and then you substitute to get 1 minus 0.65 squared and this becomes
1.731.
1.731.
Yes, doctor.
Okay. Okay, this is the error factor. Therefore, the maximum error is 1 minus this, 1 minus the error factor maximum, which is equal to 0.731, or in percentage, this is 73.1%, very high. And because the range is large, range. Okay, this is part A. Part B, when zeta equal to 0.75, when you check the R peak, it is square root of 1 minus 2 zeta squared. This would be imaginary. 1 minus 2 times 0.75 squared is negative. This is minus 0.15. 125, minus 0.125, which is imaginary, which has no peak. This will sharply go downward. This is the opposite of zeta equal to 0. Zeta equal to 0, it will shoot upward without reaching a peak. It will have a maximum value or infinite value at resonance. And zeta equal to 0.75, it will shoot downward sharply without a peak. It will decline downward. So there is no peak here to check. Therefore, the maximum error, the error factor maximum will occur at the end of the range as well. So it will be equal to 1 over square root of 1 minus 0.65 squared, all squared, plus 2 times 0.75 times 0.65 squared. Okay, so the graph for zeta equal to 0 is, this is, let's say 1 is here, 0.65 is here. So it's going to shoot this way, upward. The graph for zeta equal to 0.75. This is 1, and okay, this is the, so it will go downward this way. This is zeta equal to 0.75. Okay, part C, zeta equal to 0.65. 0.65, it has a peak, because when you check, okay, R peak, it is square root of 1 minus 2 times 0.65 squared. Okay, zeta is 0.65. And this value, 1 minus 2 times 0.65 squared, which is 0.15 in the square root, 0.3937.
37. Yeah.
Okay, so there are two things to check here. We check the error factor at peak, which is equal to R peak. No, it is 1 over square root of 1 minus R peak squared, all squared, plus 2 times 0.65 R peak squared. This is one thing. And then we find the error factor at R equal to 0.65, which is the end of the range. Okay, so this is 1 over square root of 1 minus 0.65 squared, all squared, plus 2 times 0.65, which is zeta, times 0.65, which is R. Okay, you check both of them. You take the maximum of this, of those two. Which one is the maximum? Is the answer, a required answer. Okay, so you can complete those questions, and you have the answers given. You can check with the answers.
Okay, doctor.
Okay, so this is the end of chapter 3, and this is the tutorial 8, which is the last tutorial in chapter 3. Next time we will start chapter 4, inshallah, after the Eid holiday. Today at 3 we will start the quiz. We'll have a quiz in tutorial 6.
Yes, doctor. Okay.
I will send it a reminder as well. Okay.
Inshallah.
Inshallah. Any questions?
No, thank you, doctor.
All right. Okay. Yeah.
يعطيك العافية.
جميعا. السلام عليكم. مع السلامة.